Okay, this is the second installment of our formula writing tutorials. What we're going to do now is deal with our ionic compounds. And how we're going to do that, first off, is be able to identify why these compounds are ionic. The easiest way is to look at the names. Notice that we have magnesium, a metal, phosphide, a non-metal. How do we know? Because they're on opposite sides of our metalloid staircase from our periodic table. Same thing over here. Manganese, that's a metal. Then we cross the staircase to get the oxygen, our non-metal. Non-metal and metals together like that, that's a dead giveaway that you have ionic compounds. So metal, non-metal, or metal and a polyatomic ion. The other way that we can look for, the other thing we can look for, I should say, is right here. Roman numerals, guys, Roman numerals are only used when we have an ionic compound. Okay, now let's go into writing. The first thing you have to do to write the formula for an ionic compound is to find the ion symbols. Magnesium, it's capital M, little g, it has a +2 charge because it's a group 2. Phosphide, P, that's a -3 charge. Why? Because it's group 15. That's 5 valence electrons. It needs to gain 3 more electrons. -3, -3 electrons. Now, once you write the ion symbols, the next step is what I refer to as the cross and drop. You take the number only from the non-metal and you make it the subscript for the metal. You take the number only from the metal, you cross it over here, you make it the subscript for your non-metal. Now, the way to check to make sure you did this right is to very quickly multiply your subscript times your charge. Over here, 3 times 2 gives you +6. Over here, 2 times 3 gives you -6. These two numbers are equal and opposite. +6 and -6, add those together, you get 0. If that's the case, you've written a correct balanced ionic equation. So ion symbol, cross and drop, double check. Now we need to look at it. Let's clean it up. Get rid of all this junk. We need to make this nice and neat. How do we do that? Get rid of the charges, Mg, 3P2. That, my friends, is a very nice, balanced, correct ionic formula. Magnesium phosphide. Okay. Now let's go over this one. This one has a little added bonus. This one has our Roman numeral. What does the Roman numeral tell us? It tells us the charge of our metal. Vi is 6. That means that manganese in our problem here, Mn, is going to have a +6 charge. Oxygen, group 16, 6 valence electrons, has a -2 charge. Alright, what's the next step? We have our ion symbol, we have our ion symbol. We want to cross and drop. Let's take the number only from the non-metal, cross and drop it, make it the subscript for our metal. Take the number only for our metal, cross and drop it, make it the subscript for our non-metal. Alright. Next thing we have to do is clean it up. Mn2O6. We have one existing problem left. Notice that 2 and 6 are both divisible by 2. If you can simplify, you must simplify both of the subscripts. This problem will end up being MnO3. That is your final, correct, balanced chemical equation for manganese 6 oxide. We took our ion symbol, we took our charges and crossed them over. We got this new equation down here, Mn2O6. We divided both of them by 2, and you see that when you do that, you get Mn1O3. Mn1O3, don't write the 1, it will exist right there, and they're good to go. Okay, one last part here, and this is with ternary ionic compounds. Ternary, the word ternary, means that we have a polyatomic ion. So that means we have a metal and a polyatomic ion. Basically, it's the same thing, except for you already know the charge because you have the polyatomic ion sheet. Here, you know the copper is going to give +2. We write that down, Cu plus 2 charge nitrate. If you look at your polyatomic ion sheet, it's NO3, negative 1 charge. Cross and drop now, guys. I'll bring this down. 1 comes over here. R2 crosses, drops over here. Let's rewrite that and clean it up a little bit. Cu, notice that I'm not ready for 1 because the 1's understood. Cu, NO3 in parentheses 2. Now, the reason we have to keep the parentheses around our nitrate is because if we don't, it looks like this. NO3, 2 could be written like this. That looks like we need 32 oxygens. We don't need 32 oxygens. We need 2 NO3s. So be very careful in how you write polyatomic ion. If you need more than one of them, you have to keep it in parentheses. You need to cross and drop outside your parentheses. So what did we do here again? Let's go back through one more time real quick. We took the formula, symbol for copper. We know that it's a plus 2 charge from our Roman numeral. We took the symbol for nitrate from our polyatomic ion sheet. We know it's a negative 1 charge. Cross the drops, Cu1, NO3, 2. We bring that down and rewrite it without the 1, of course. Cu, NO3, inside the parentheses 2. That tells me I need 2 nitrates for every 1 copper. 2 nitrates for every 1 copper. That's your finished final chemical formula for copper to nitrate. The only difference, because we have an ATE ending, you have to look at the poly ion sheet. That's for the ATE endings. That's for the ITE endings. And then there's a couple extra ones I know, like hydroxide, cyanide. Be careful.